What's up, guys? Many of you have commented or messaged me or said in live sessions about that trig substitutions final prep review problem. I want to let you know I'm going to cover up things along the way, but I'm trying to actually show how it's not a U sub, but we can connect it back to SOHCAHTOA because square root 4x squared plus 9 looks like a squared plus b squared equals c squared. Three sides of a right triangle, 3 and 2x, actually form the opposite and adjacent sides. So we can write that as a tangent function. Tangent of theta is 2x over 3. Solving for x, since the integral has x in it, and also further differentiating x, we're going to do a substitution of the original integral where we replace x with 3/2 tangent theta and dx with its derivative, 3/2 secant squared theta d theta. Everything that's in x dx is going to be substituted. That's a trig substitution. That's where the trig substitution happens, is in the substitution steps. We continue to arithmetically simplify. So for example, you're going to square 3/2, which is 9/4. The 4's cancel. You can factor out 9 because 9 is in both terms, and the square root of 9 is 3. 3 on the outside, 3 on the inside, they cancel. Tangent squared theta plus 1 is a trig identity. It's secant squared theta, and that's being square rooted. So we really wind up with secant squared theta over secant theta. Those cancel, leaving us with the integral 1/2 of the integral secant theta d theta. I don't know what that is. I wouldn't expect you to know. I did look it up, but a little math magic lets us know that the antiderivative will be 1/2 natural log of the absolute value of secant theta plus tangent theta. Don't forget plus c. Again, that's totally math magic. You should look it up. It'd be nice to know. Going back to the right triangle, the relationship for tangent, we've already identified. It's 2x over 3. So let's substitute that out. Put 2x plus 3, 2x over 3, where tangent theta is. Also use in the right triangle. In the right triangle, the hypotenuse, secant is hypotenuse over adjacent side. So we can write that fraction for secant theta, and bada bing, bada boom, kind of ran off the screen there. But our answer uses, hopefully I'll adjust it here, the natural log, 1/2 the natural log of, and then that whole thing. I'm going to add a still frame here, so I'm going to kind of pause and let you kind of reflect on it. This is what I'm expecting the answer to be. Thank you very much for watching. Go ahead and give this video a like, and we'll see you next time. Thanks for doing some math with me.